all. Thank you for joining me here, and thank you, Broadband Forum, for giving me the opportunity. So let me introduce myself. My name is Hande. I'm a product manager at Motif. I manage the Home Device Manager product, which is a USP controller. I've been in this industry since 2007, on and off, mostly on. I did a couple of other things in between, but it's something that I'm passionate about, so I came back. So today I'm going to be talking about the multi-controllers, and Marcel also touched base on that today in his presentation. My angle will be more from the multi-vendor perspective. What happens when you have multiple controllers from different vendors? What might be some of the challenges that you're facing, and what are the keys to success? Of course, it would be a crime if I didn't start with first the advantages of USP, because even though we have been repeating this for some time, and USP has been published in 2018, so it's been 6-7 years now. It's still new to some of the operators. We have now, Jason shared the statistics, right? It was 32% that are already on USP, so we have still 68% that are new to it. And unless people really get their hands on it, it doesn't sink in. So we keep repeating, what are the advantages? So first of all, and Günther displayed it very nicely, right? We have always-on communications, which gives us these real-time, event-driven updates and communication between the devices and the controllers. And this itself enables a lot of other use cases. We talked about managed Wi-Fi use cases when you have complex mesh networks, where you depend on that real-time data. Other use cases, especially with the smart home, IoT device management, etc., this becomes really critical when you also look from the troubleshooting and diagnostics angle. It leads to faster issue resolution and also savings for operators. The second improvement of USP over TR69 is security. Yes, TR69 also supported end-to-end encryption, right? We could send the messages over HTTPS, but TR69 was encoded in SOAP using XMLs, right? And XML, if you ever look at the vulnerability lists, XML is a popular one there. So we don't have XMLs anymore. USP is encoded in using protobuf messaging. And one critical thing is that it allows role-based access control, which is very important when we talk about multiple controllers, because it's going to be very important. One thing that USP does not have compared to TR69 is the connection requests over HTTP, which was another rather weak point. The third advantage is more efficient or improved data collection. When you want to do, especially AI, ML, analytics on the cloud side, so not on the device, but on the cloud. And when you want to get those notifications or pull data from the device, you want to get as little as possible, right? You don't want to waste your bandwidth. You don't want to flood your data lakes with data that's not unnecessary. So USP has mechanisms like the search, etc., search expressions that allows us to exactly pinpoint which data we want. So that's quite an improvement over TR69 in that sense. And last but not least, and it's the topic of this presentation, is the support for multiple controllers in TR69. We had a single ACS, and that was the only thing that could manage the device remotely. Whereas in USP, there could be many controllers. And so I'm going to be diving into that now. All right. But why am I talking about this, in fact, and why did I choose this? Because now that a lot of my customers also, they are moving to USP or considering to move to USP, this is a question that I get a lot, almost every week. They're asking about how they're going to manage if they have multiple controllers, what is the advice that we give to them. So this is really popular, and almost all of my customers that are on USP, they have multiple controllers. And when I say multiple controllers, HDMI product also comes with multiple controllers, but I mean a third-party controller next to mine. So the first reason is, okay, there is an increase in the adoption of USP. It's increasing at an increasing rate. And the reason for that is, of course, in the beginning, I think operators, the adoption was rather slow in the beginning because with every new technology, it takes time to take off, but the devices were not compatible. They didn't really see the use cases or understand the use cases that they could do with USP, and they didn't see the need for it. But now it becomes more obvious with the explosion of connected devices, smart home ecosystems that are requiring flexible concurrent device management. And then we have the Purple OS, RDK, Purple Foundation, RDK, bringing up these open source operating systems, which are maturing and which are enabling us to use standards to do software module management or running applications on containers that enables the app-enabled service gateway concepts where we deliver value-added services to customers or consumers. And those value-added services, they might need additional controllers, or they might have their own controllers. And I hope they do, and they don't rely on some proprietary technology to do that, and they just keep using standards. Rise of third-party integrations, IoT platforms, and smart assistants. So all devices are connected now. Even my toothbrush is connected. I don't want it to be, but it is how it is. And then we have voice assistants. I'm really looking forward to Broadband Forum Integrate Matter so that I can have my own personal controller at home so that I can bypass Google Home because, you know, we're a multinational home. So we speak a mix of languages. None of us are native English speakers, but all our devices are set to English. So you can imagine the struggle I'm having with Google Home, not understanding me. And I keep using it, but I don't know why. I mean, I'm complaining yet keeping you. So talk about customer stickiness. All right, so, and last but not least, we have the consumers demanding direct app control alongside ISPs and partner services. Of course, we can debate whether this requires a separate controller or they should be just using the standard APIs through the existing controller. That would be my choice, in fact. I have a controller for that, but it's possible. It's possible. As I said, I'm going to give some practical advice on how it looks like. So with multiple controllers, we get improved modularity and flexibility in service delivery. We have separation of concerns. Normally, the operators normally have a primary controller that's responsible for the lifecycle management of the device. You do your provisioning, maybe your service configurations, your firmware upgrades, etc., through this primary controller. Then you might have secondary controllers that are specific or focused on specialized functions. Wi-Fi optimization is one popular one. Telemetry, data collection, software module management, performance monitoring, speed testing, or monitoring the energy consumption of your IoT devices. That could be a secondary controller as well. I'm going to go into details about how these secondary controllers get known by the device, but that's a bit later. So I want to talk about this deployment overview. Now, in this example, I put here two scenarios, in fact. Let me see, how do I point? All right, okay. So we have one scenario here on the left-hand side where we have two controllers sharing a broker cluster. And on the other side, we have two controllers completely isolated. I put here MQTT and Stomp, but you can put whatever you want. It doesn't matter. It could all be MQTT, all be Stomp. But since I wanted to make a point and have the broker clusters, I didn't put here web sockets because it doesn't go through brokers. But anyway, so operators ask me, how do we deploy the additional controller, the third-party controller? So initially I said, yeah, it needs to be totally isolated, but then I changed my mind. And why? So on the left-hand side, where two controllers are sharing a single broker cluster, they are still having their dedicated topics. So not one controller is seeing the messages of the other controller. So they have their own dedicated topics. However, the agent, the device, it is maintaining a single persistent session towards the broker. Yes, it's subscribing to multiple topics that belongs to controller A and B, but the session is a single TCP session. So that's there is only one session here. So this has pros and cons. The pros is that the device is using less resources because it's only maintaining a single session. Then as an operator, you are having a smaller footprint with respect to your broker's deployment, because if you have different brokers, you will have more servers. What are the disadvantages of this? There is less isolation. So if your broker were to go down, well, hopefully there's high availability, but let's say, think about the worst case scenario, everything went down, both of the controllers would be impacted by that. And you could also argue that, okay, yes, the controllers don't see each other's topics and messages, but it's still sharing a single TCP session. So you could argue that it's less secure compared to an isolated one. So on the other side, we have the device maintaining two TCP sessions, two persistent connections. So this is causing more overhead on the device. And from one of my customers, I heard that it was quite significant. Then you have to maintain two broker clusters, two isolated broker clusters, meaning you will need more resources, more servers or cloud resources. However, this is more isolated, and of course, you could say that it's more secure. So in the beginning, I really wanted to not share anything because I want to, of course, protect my application and from what might happen with the other controller. But I changed my mind because we have means, or we have protections in place that can protect ourselves, be it rate controls, being payload size restrictions, being all the tools that we have for monitoring the system and the brokers. So we are now confident that it's okay to have the left-hand side scenario. And almost all of the operators that I know are going for this approach now. Of course, this is only applicable if they are using the same type of MTP. All right, so how does the device know about these additional controllers? There are various ways. One is that it could have been pre-provisioned on the agent at the factory or at the firmware. It can be configured via the primary controller. So primary controller let the device know. It could be done through a user or management interface on the device, or also these additional controllers can self-advertise themselves over MDNS, DNS, DHCP, etc. Now, I want to, again, dive into the popular one, which is that a secondary controller is onboarded or through a primary controller. So how does that work? It's rather simple, very simple, in fact. So you have an administrator. So administrator needs to go to the new controller and tells the controller, okay, here are the topics. Oh, and first, in fact, it needs to go to the broker and create some user for that new controller. So because it needs to authenticate when it connects to the broker. So let's assume the authentication, the credentials, etc. are okay. Administrator would go to the controller B and configure the topics, create and the credentials on the controller B. Then controller B will connect to broker with its credentials to the new topics. And this establishes basically the connection between the controller and the broker. Then the next part is about letting the CPE know that there's a new controller. And in that case, your primary controller will tell the CPE, look, there's a new controller. Here is the information. Here are topics. And CPE will then go and subscribe itself to those topics. And it will send an onboard notification to the new controller. And that's basically it. It's very simple. All right. So let's talk about role-based access control. So this governs what each USP controller can access or control on the CPE. And this is very critical when you have multiple controllers, especially from different vendors where they might be, doing or operating on the same objects or on the same services. So with role-based access control, we have roles that defines permissions on data objects, commands, and notifications. And why do we need this? Because there are some challenges. Marcel this morning also mentioned brain split when two controllers are trying to do the same. So as far as I know, or the last time I checked, USP specification does not define a prioritization model, right, for controllers. So it's up to agents implementation on how to handle the priority. And if you have an ecosystem consisting of different devices, so you're not working with a single vendor or you are not owning the device agent, this might be a bit of a challenge because you don't know what behavior or what kind of behavior the device is going to exhibit. Same for conflict resolution. If something happens at the same time on the same object, how does the device behave? Again, it's up to device. It can deny it or run it in parallel or run sequentially, so we do not know. Thirdly, the resource contention. Even if you go with a shared broker, the device will be subscribing to more topics. There will be more operations transactions happening, so it will be using more resources for sure. Debugging, I hope we don't need this. I'm sure we will. So multiple controllers might make finding the root cause of issues a bit more challenging. So just for your information. Now, how can we overcome these challenges? So role-based access control is very critical. If you separate your controllers and define clear roles and policies for controllers to segregate the territory, you can make it work. So make sure there is little or no overlap so that you can avoid conflicts. And when you onboard controllers, make sure that they are robust and scalable and not a POC, so that you are confident that the system will still be healthy. Security, so make sure everything is encrypted from broker to controller and also broker to the CPE. You're using mutual TLS. So follow the security best practices. And last but not least, very important, especially if you're sharing brokers, you need to monitor your brokers, controllers, sessions, what are the connection establishment rates, the teardown rates. So you need to make sure that you have the tools in place to monitor and also do the actual act of monitoring. And also try to reduce the footprint where possible, because we always talk about servers and CPUs as commodities, but they use energy at the end of the day. It's not good for the planet. All right, so that's about it. So a few words about Motiv, which is not the sponsor of this meeting, but will be the sponsor of the next one.
Well, of the member meeting, you guys are sponsors of technically of this meeting that we're doing right now.
All right, so Motiv was founded in 1997. In fact, when I joined Alcatel-Lucent back then in 2007, we were co-developing HDM together with Motiv, and then Motiv was bought by Alcatel-Lucent, and then Nokia bought Alcatel-Lucent. However, last year, a company called Lumen carved out Motiv from Nokia, and Motiv is again a standalone company focusing on what we do best, and that's the device management. So we operate in device management. We manage CPs, we manage IoT devices, mobile devices. We have entitlement server, RCS, ECMIS, and provisioning products, and also service management platform for customer care agents. We have a large customer base, very big operators, tier 1 operators, but also tier 2 operators. So that's about it. That's what I wanted to share today. So any questions?
Thank you very much. Yeah, Tim.
Just on the 4 problems, the second one, the overlap, is that, do you see a lot of services contending for the same resources?
Yeah, especially on the Wi-Fi side, yes.
So you have multiple services that are actually trying to do kind of active Wi-Fi management?
Yes.
Interesting.
Yeah.
Tell them to stop it.
What do we...
And I noticed you had both MQTT and Stomp. I noticed you had both MQTT and Stomp on that slide. Yeah. And your point being that, it really only depends on if they're all using the same.
Yes.
I don't know if anyone has any opinions or feedback on using WebSocket for anything, but just so that people know that it is the other MTP.
There is yes. WebSocket is another option. Exactly.
All right.
Thank you.
Thank you very much.